It's a quite substantial work that is being presented as of now, and it has relevance to a lot of NFDI tasks. So therefore, it is really nice to have you here as of today to give this presentation. We welcome Anna-Lena Lorenz, who is a community manager at the TIB, and she has a PhD in physics, if I'm informed correctly. As well, we have Sören Auer, who happens to be a professor for data science and digital libraries at the Gottfried Wilhelm Leibniz University in Hanover, and at the same time is director of TIB. His previous career path includes also University of Leipzig, of course, and University of Bonn, and he has been a director at Fraunhofer IAS. Finally, last but not least, we welcome Kheir Eddine Farfar, who is a research software engineer at the TIB and who is deeply engaged in creating the Open Knowledge Research Graph. In the talk, we will learn a lot about knowledge graphs and a particular knowledge graph, which aims at the research community. And frankly spoken, this is at the heart of our NFDI community tasks. So welcome to all the three of you. Welcome to the complete audience, and the floor is yours.
Yeah, thank you very much, Jörg, for the kind introduction. We are also very happy to be here after a summer break. And I will start with the presentation, and later on, Kheir, Eddine, and Anna-Lena will join me and focus on some more specific aspects. So I hope you can see my screen. And I actually want to start with the presentation with a few slides introducing what we aim for with the Open Research Knowledge Graph. It's now a project which almost, or a service which we developed almost for 5 years. So it's a demonstrator for ERC project I was working on in the last 5 years, but we increasingly also integrated now in the NFDI. So for example, we work on use cases in NFDI for ING. I will show an example there, also in NFDI for data science, and NFDI for energy, just to name a few. But what is our intention with the Open Research Knowledge Graph? So let's maybe take a step back and look a bit how information flows have changed in the digital era. And if we look, for example, at mail order catalogs, street maps, phone books, or encyclopedias, these different information domains have been completely disrupted, and no one nowadays would order a product from a scan of a mail order catalog or use a scan of a street map for navigation from A to B. Yeah, so we have developed very digital-born services for accessing these kind of information, for planning trips, for e-commerce applications, for encyclopedias, and many other domains. And these are not just like pseudo-digitized analog artifacts, but really truly born digital services which allow to zoom into the data, which allow to access more dynamics. The business models also completely changed. Actually, old companies went out of business. New startups have conquered the market and grown to billion euro companies. There is much more focus on data, of course, on interlinking of data, on services, search in the data, and also the integration of crowdsourcing data curation plays a key role there. And now, how is it in scholarly communication? Of course, we now have this attention in the NFDI on research data, but still a main paradigm for knowledge exchange is also scientific articles, scientific papers, and there not so much has changed. Of course, making the data available is a great step, but we also need to link it to the description of the findings in articles. We need to structure the description in articles. And currently, we haven't really completed this step, and we have a number of problems, like we have a reproducibility crisis. Majority of experiments are hard or not reproducible. We have a publication flood. We have 3 million publications every year, and it continues to rise, and that also results, for example, in a deficiency of peer review, and it's a deteriorating quality also of peer review because it's more and more difficult to keep an overview. We as researchers often basically look for the needle in the haystack. So this problem of not having maybe a right mechanism for publishing scientific findings results also in a lack of transparency. Much information is hidden in the text. We focus, of course, a lot on identifiers in terms of DOIs for document identification, in terms of ORKIDs, ROR identifiers for organizations. But we actually would like to identify also the concepts deeply in these documents. We want to integrate results from different sources. Machines can hardly assist us. Maybe some of you remember there was a language model, Galactica, released by Facebook a few months ago, and it had to be taken off, basically shut off, because it was hallucinating simply too much. And I think machines can assist us well if we have structured and organized the information in a good way, and with the scientific publications, this is hardly usable there. So also collaboration, overview I mentioned are problems, and each one of you knows that when you search on Google Scholar for a certain for a certain keyword, you get thousands, 100,000s of results. This year is actually already 4 years old, the screenshot. Meanwhile, you find almost 1 million results for the CRISPR keyword. And if you are then interested, how good is this method, genome editing method, what specific has it, who has applied it to butterflies, you are lost in this large pile of information. Yeah, we want to address that. How can we fix that with the Open Research Knowledge Graph? And our vision is to integrate, to describe overarching concepts like research problems, definitions, research approaches, methods, different artifacts like publications, data, software, audio, video, images, and of course, ontologies and knowledge graphs, and then also very domain-specific concepts, which vary a lot in the different scientific domains, and even more so for each research problem. You have different concepts, different properties, relationships to describe research contributions, and we want to give them an identity in this Open Research Knowledge Graph, and then also describe basically the relationships between them in a systematic and semantic way. Yeah, so this is the overall concept. And now I would like to show you some examples how it works. As I mentioned, we have developed this service for the last 5 years. So we have meanwhile almost 1,500 users. We have 40,000 contribution descriptions in the Open Research Knowledge Graph. This is still a very small drop maybe, but we of course have the ambition to scale this, and hopefully in a few years to make this resource valuable for millions of researchers. So when you go to the homepage of the Open Research Knowledge Graph, you can browse by research field. Yeah, for example, we can go into the engineering research field. And then you have the subfields, and when you scroll a bit down, you actually can see comparisons. So comparisons, of course, you can also look at individual papers, but more interesting is actually these comparisons of the state of the art. We want to give an overview of the state of the art for a certain research question. And if we ask the research question, how do we have to transform Germany's energy supply, or how much capacity in renewable energy do we have to build up? This is a question, for example, which is tackled in the Allen use case in NFDI for ING, or also in NFDI for energy analysis. We go into this direction. We have here a comparison, and when I select this comparison, I get an overview of the contributions to answering this research question. And these contributions are, of course, traditionally papers. So we see here a table basically with columns. Each column in this table is a paper. It doesn't have to be most of these publications, of course, are peer-reviewed formal publications, but here in that case, we actually have studies which are published, and some of them are also not peer-reviewed. And overall, for this particular research question, we have 25 studies, and actually only when you look at them together, you get an overview and you can answer certain questions. So by just looking at one study, you have maybe one individual answer, but by looking at the canon of different publications and contributions to this research question, you get a more comprehensive overview. And we have described basically the gist of the information from these different studies. For example, very important is what energy sources are considered. Yeah, so in the first case here, in the study, klimaneutrales Deutschland, bioenergy, geothermics, hydropower, import, and some other sources. And then there are different scenarios. So the first study here, for example, assumes a scenario of 100% CO2 reduction till 2050. And there are many more properties. Basically, you can see this here on the left, the properties which describe the contribution or the findings of these different studies. So now we already have an overview table. We can also scroll here to the right. So this is maybe already a bit more, how to say, intuitive than, or gives a better overview than reading 500 pages of paper, which would be probably the combined amount of all these studies together. But since this is not only a table, it looks a bit like an Excel spreadsheet, and you actually can interact with the Open Research Knowledge Graph like with an Excel. You can add, fill out such tables in order to create overviews of the state of the art for your domain. But what we have here is actually really a deep structure and a knowledge graph which is behind. So when you mouse over these different cells here, you actually see the resource IDs. Similarly for the properties on the left-hand side, and there is this comprehensive, also machine-readable resource in the background. And that allows us to create different views of the knowledge in the Open Research Knowledge Graph. So that's what we see here on top. For example, we can click on one of these visualizations, and then we get a view, a different visualization view here. For example, the installed capacity in gigawatt, which is required for the transformation, and we see how this differs between the different studies. So some studies assume that it's between 600 and 1,000 gigawatt. Others are much lower here, but we can see that probably most of the studies assume we need around 400 gigawatt, for example, for this energy transition. And that gives you a condensed overview of the viewpoints of these different studies, which then can be scrutinized and questioned. So these kind of comparisons are also, you can export them. So it's really like an infrastructure. You can export them as LaTeX, as CSV, as RDF, of course, as linked data, the citations. You can launch a Jupyter notebook and directly work with the data in the knowledge graph. And in this comparison, we have the history, so you can see prior versions, a quality report, the top authors who contributed to this research problem that can help, for example, to find authors for peer reviewing. You can share the link and point others to this resource. It can be published. It gets a DOI, so which you can see here on top as well. Of course, each of the studies might have a DOI and is published somewhere, but also this overview comparison becomes research data in itself. It's indexed in DataCite, and then is also a scientific contribution which can be used. On top here, you see also the buttons you can edit. You can add another contribution. You can visualize the results, or And maybe I show you one particular contribution. So let's take here this one, Klimaneutrales Deutschland. If we click on that, we basically get an overview on this particular contribution. So we have on top here the energy sources and below a scenario which is described. And when I'm logged in, I can also click the edit button. And then basically this view converts into an editable view, so I can edit values. And I just want to show you that we can add additional properties. For example, we can start typing something. And I, in the background, it basically searches for existing properties. It also not only looks in the Open Research Node graph, but also in other knowledge graphs. So actually we envision a network of interlinked knowledge graphs, which represents knowledge from different domains. So here in that case, you also see, for example, Wikidata or geonames, but I now use the property here from the Open Research Node graph. I could also create a new property because, of course, this structure, these properties for describing research contributions should evolve. Yeah, they should not be fixed, but each new research problem requires also new properties and new structures. And then once I want to add information here as an object of this triple, basically of the statement, I can again also start typing something. I can either create a new resource or select one from the graph or also from this network of graphs. For example, here we could also link to Wikidata, or if you scroll down, there should be also somewhere geonames resource. You see also, yeah. So, but let's select here, for example, the one from Wikidata, and then we have linked this concept, this resource, actually to the respective Wikidata resource. And from there, we can also import. So we see here, we show basically this resource Hanover also inside the Open Research Node graph, but we have the link to the Wikidata entity, and we could actually use the statements like geo-coordinates, for example, directly also for querying. So let's go back to our contribution description and maybe delete what I added here, because this, of course, for that particular resource doesn't make sense. But on the right-hand side, I can also see the timeline, who has added what at what time, and I can see basically the trace of the evolution of this particular resource, the provenance. We also have integrated these kind of smart suggestions where I can annotate a paper, for example, or get recommendations. We are in the process, of course, to improve this and to add more automation features so that you get suggestions, that we automatize this curation of the content as much as possible. It's a bit challenging because we don't have yet good training data, but the more data we collect, the better these suggestions will also become over time. Okay, I'm stopping to edit here. We can also view the graph. That's of course also possible. So here we then see this particular paper. So the study Klimaneutrales Deutschland. We have the metadata here in yellow on the left or right-hand side. And then on the left-hand side, we have the actual contribution description with the properties. And we could then also add more details, for example, by adding the depth and zoom into more details in the graph as well. So this was an example from engineering, but I would like to briefly show you some examples, maybe also from other domains, because before we go on. So we also have here another example from engineering, but more from really manufacturing engineering is this one, which describes tailored forming process chains. And you can see also the same concept is applied here. In the column, we have different publications and contributions from these publications described. And then we have properties here, for example, they deal with different material groups like steel and tackle different alloys and have different tailored forming processes, which are described here in detail. And also there we can create visualizations, for example, the frequency of different methods which are used in these different tailored forming process chains, and can analyze basically the research data from different sources. And one example from the life science area is also for infectious diseases is the COVID-19 reproductive number estimate. So here we have 31 contributions in this table, and that was in the beginning of the pandemic quite important, or for new infectious diseases. If you want to determine this basic reproductive number, how basically the disease spreads, then you need to perform different studies, and these different studies can be added to the Open Research Knowledge Graph. So in a way, the Open Research Knowledge Graph is also something like a digital platform for meta-analysis or survey papers, which can be done here. And as a result, we can also have here different visualizations. For example, the R0 estimate from the literature. We can see what probably the consensus is. So here in that case, most of the authors agree it's around 3.5 in average. There are some outliers on top and below, but in general, it's around 3.5. And this was just here aggregating information from 31 papers, but you could even do this for all infectious diseases. And this is a Jupyter notebook which aggregated this information. So, and there you could potentially create overviews over thousands of papers. And here we have a visualization which illustrates the infectious disease and a two-dimensional visualization. Where you have the basic reproductive number, so the contagiousness on the x-axis, and the case fatality rate, the deadliness, on the y-axis. And we can see here SARS-CoV-2 has a similar characteristics like dengue fever, for example. And creating such condensed overviews over the state of the art requires really aggregating, synthesizing research from thousands of papers, and this is something which we want to facilitate with the Open Research Knowledge Graph. Good. We have also, like, you can access all the data of the Open Research Knowledge Graph. So, for example, here under Tools, you have data access. We have a REST API. There's a Python package. There is a Sparkle endpoint which you can use. You can download the RDF dumps. So if you want to get an overview of how much data is in there, you can generate the statistics here. So we have 27,000 descriptions of contributions from papers. We have 1,300 of these comparisons, these overviews, which I've shown you 3 now. We have almost 1,500 users, 37 organizations who are participating, and also a number of observatories which focus on specific domains. I think Anna-Lena will present this a bit in more detail. You can also see here that it's part of NFDI for data science on top. So we also link to the other NFDI for data science services. And our aim is, of course, a seamless integration with these services so that you can directly access functionality from different services. And we would be, of course, very interested and happy to also integrate with services from other NFDI initiatives. We have quite comprehensive documentation, meanwhile, also about the different features of the Open Research Knowledge Graph. You can import data from CSV, for example. We have a lot of use cases where people create such overviews of the state of the art in Excel tables, and then you have the opportunity to also upload them to the Open Research Knowledge Graph and ingest them. We have templates. That's a feature Kheir Eddine will present in more detail. And then there are also a number of other possibilities. In addition to the comparisons and visualizations, you can create whole review papers in the Open Research Node Graph based on the content, for example. So if we select here one, you can basically also edit a paper and then directly add into this paper this dynamic content, which is comparisons, but also visualizations and other things in these kind of digital-born review papers. We have also lists. So this is a feature because in the beginning, often you don't right away have a structured description of a research problem, but you have maybe a literature list. So you can start with this list of literature and then organize it step by step into a comparison later on. So it works a bit similarly. You can edit this like a simple article, but as part of the article, you basically have then papers organized in different categories. And as a next step, you could then create these kind of structured comparisons out of such paper lists. We also want to integrate the Open Research Node Graph with conferences and journals. So there are already a few conferences using the Open Research Node Graph for the peer review process because such a comparison gives you a much better overview of the merits of a certain contribution so that it can be scrutinized by the peer reviewers. And our vision is that the Open Research Node Graph or such comparisons become part of the peer review process and that you deliver along with your submission to a conference or a journal an overview comparison to the reviewers. And as a side effect, you have created structured content about your research, described your research contribution. And this is one way how we also want to attract more users in the future. Yeah, so this was a brief overview of the Open Research Node Graph. And at that point, I would like to hand over to Kheir Eddine, who will zoom into some more details, in particular with templates and benchmarks.
Yeah, thank you, Sören. I will share my screen. So hello, everyone. My name is Eddine Farfar, and today I'm going to talk about benchmarks and templates in the Open Research Knowledge Graph. And for that, just a quick overview for this presentation. So it will be in two sections. In the beginning, we will have an introduction about the benchmarks and the templates. And in the second phase, we will have a demonstration of the leaderboard template and how we are going to add a paper using this template. And also we will see this paper in the benchmark list. So for the benchmarks, as you know now, like the data presented in the PDFs, and we try with the benchmarks to organize this data of experimental research in artificial intelligence or in computer science in general in our knowledge graph. And as an example, this paper is addressing the research problem image classification. And as you can see here in the abstract, there is different concepts are covered. So there is this method called convolution and self-attention is used on the benchmark data set called ImageNet, and it reports some results of its performance. And once we collect this data, we try to create a leaderboard and to show like the performance of different algorithms on this benchmark data sets. And to answer the question of how we are going to collect this data from users, basically we provide like a template system which empowers domain experts to define the structure of contribution data, and by that with specifying the target research field, as an example, the computer science, and also the list of properties for that specific concept, like the data set or the source code. And for each one of those properties, we also allow to define the constraints, like for the evaluation, it should be a quantity value, or maybe for the source code, it should be a URI, and so on. And based on this, the definition of structure, we generate user-friendly input forms and perform data validation to ensure the quality of data. As an example, here you can see the paper And it has some metadata like the authors and also the research field it is in computer science. And also we more focus on the contribution data, which is the knowledge described in the paper and not like the metadata. So for the contribution, it is like using some model, and it addresses the research problem image classification. It also reports some benchmark on a specific data set, and it has some evaluation metrics. Now for the live demonstration, I will leave this presentation mode, and they will take you to orkg.org to show you how this works. So let's first have a look at the templates. So to see the templates, we need to go tools and then templates. And here, as you can see, we have like more than 400 templates, and each one of those is defining the structure of a contribution for a certain concept in research. So I'm interested in the template called leaderboard, which is used for the benchmarks, and I can visit it from here. And as you can see here, we have like the name of the template is leaderboard, and also we have some description to define this template. And also we can specify when this concept will be used. So for the leaderboard template, it's usually applied on the research field computer sciences. So once the user added new paper to the knowledge graph that it's in the computer sciences research field, we try to suggest the leaderboard template automatically. And then we provide this list of properties, which are listed here, like we have benchmark, we have the model, we have the source code, and also the research problem. And each one of those properties, as we said, we can define the constraints for this. As an example, for the research problem, we have the problem. It has to be an instance of the class problem, and also the source code, it has to be a URI. For the model, it has to be a model or an algorithm. And for the benchmark, it can be also an instance of the class benchmark. And each one of those ranges or classes, it can have like also a template, which is like a sub-template for the template leaderboard. And to give you an overview of how these templates are connected together, we provide this like view diagram to show like, as we call it, class diagram. If you are familiar with the data modeling, I can click here. And as you can see here, we have like, I can zoom in on the leaderboard template. As you can see here, we have the list of properties. We have benchmark, model, and source code, and research problem. And each one of those can be linked to a different template. So for the benchmark, it can also itself be a template with two properties, let's say data set and also the evaluation. And the evaluation by itself, it can contain a value with the quantity, with like some metric, and also some numerical value and the unit. And for the research problem, it can have like a description. Maybe it can have like some sub-problems, which are also by themselves research problems. And this template system is also supports some standard ways of describing this kind of constraints for knowledge graphs, like as we call it, like shackle shapes. So we can import shackle shapes, and also we can export it to this format. And let's now add a new paper which uses this template. So first of all, you have to be to make sure that you are signed in, and then you click on add new. And then let's click on paper. And here we provide like an input form to simplify the ingestion of metadata. We just ask for the DOI, and I have some notes in my computer here to add new paper. So we have this DOI, and I will just click on lookup, and we will fetch the metadata from Crossref. So here, as you can see, we fetched the metadata. We have the title, we have the list of authors, and also we have the publication year. I can also maybe complete this data by filling like the missing data. Like for this case, we have the publication month is not provided. I can provide it if I know it. So let's say if it's in March. And also there is a required field, which is the research field. And I also have to provide this value. As you can see, ORKG already analyzes like the title and the abstract of this paper and tries to guess the research field of this paper. So as you can see here, it already provided like it can be in computer science, machine learning, or maybe artificial intelligence. And for this example, I will just select computer sciences. After that, I can just click on add paper, and this paper will be added to the knowledge graph. So now we are in the view paper mode. As you can see, we have the list of authors, number of citation maybe, and also the research field computer sciences. And this is the contribution data. As you can see now, we have no data because we didn't add yet like the the knowledge represented in the paper, but also we have like some smart suggestions, or we have like some artificial intelligence models that tries to extract some statements automatically from the abstract and also the title of paper. And for this example, I'm going to ignore just these suggestions, and I will use like specific template, which we call like the leaderboard template. And to add new template, we can just click on templates, and we open the gallery of templates, and I will click or apply the template called leaderboard. Once I click on it, it will be applied on this paper, and it will add a set of properties that as we defined them in the template system. So we have benchmark, model, and also source code and research problem. For the research problem, as we said, like we have in this paper, it addresses the image classification research problem. I will just add it here. As you can see, when I start typing the research problem, it automatically gives me some suggestions for the research problem, which are already in the Open Research Knowledge Graph. So I will select this image classification, and also I can provide the source code, which I have it here also in my notes, and I can provide the value, and it has to be like a URL. As we said, like we have some data validation on these constraints. So if the user tries to enter like a number, we see that it doesn't accept this value, and this will guarantee the quality of data that we collect from users. And I will just copy the URL of the source code here. I can add multiple value. I have also another source code for this specific approach. And now we need to provide the model or the algorithm I use it or reported in this paper. And the model is called Basic L Lion. I will just create a new resource because it doesn't exist yet in ORKG. And I can also click on this resource and provide more description, because as you can see now, there is no description yet, but I can provide it as a user. So I just click here and then add a new property. Let's go set description. And then I have already some notes here. I'll just copy the text of the description, and it has to be like a text and not a resource, and hit create. I can also embed some images. Let's say I have like some image that I got from this paper, and I can provide it to ORKG and embed it directly in the view paper. So I copy the URL. So this is the URL, and embed like and include the link to the image. As you can see here, I have already like an image defined in this resource. So as you can see now, when I hover on the resource, I can see directly the description of this algorithm or method applied in this paper. And for the benchmarks, I just click on add value to give the evaluation provided in this paper. When I click on add value, I have already like a list of properties that are defined in the template benchmark, and I have to provide like the data set and also the evaluation. And for this paper, it uses the benchmark data set called ImageNet. I can just provide the value here, ImageNet. And also for the evaluation, I can just hit add value. So for the quantity, has quantity kind, I can provide the metric used for this paper, and it's like top 1 accuracy. As you can see, I have already some suggestions which are stored in the graph. So we know that for the metric, it can be one of those values, and they can create also a new metric if it doesn't exist. So for this one, we have already top 1 accuracy. And for the values, I can just click on add value, and then I will be provided like with 2 inputs, one for the numerical value and also for the unit. For the numeric value for this paper is 91.1, and the unit is %. As you know, like we have already like linked to external ontology, as Sören mentioned in the presentation. So we can see that the % is already defined in the external vocabulary, which is like udt.org. Let's go back to the contribution node. Now we have already defined like the knowledge represented in the paper, which regards to this evaluation of a specific method called basic L with some metric and also source code. I can stop the editing now and maybe show you the graph for this paper that I already added. Just for simplicity, I will try to collapse this research field. And as you can see here, we have the paper node, we have some metadata like the authors, the publication year, maybe the publication month, and also we have a link to the contribution data, which is what we are interested in. So we have the source code, we provided two source codes. We have the research problem image classification, and also we have the benchmark. And we can also expand the benchmark to see on which data set it was evaluated. And also we have the values for the evaluation itself. As you can see, we have the metric, which is top 1 accuracy, and also the numeric value for the quantity. Here we have like 91.1, and also the unit is percent. Now, let's say if we collect more papers in which addresses this research problem image classification for this specific data set called ImageNet, we can just go to ORKG and then view and click on benchmarks. And here we list of benchmarks that we have already in ORKG, and originally they are imported from papers with code. And as you can see, we have more than 1,000 research problem already for the benchmarks. And for our paper, we added it in the image classification, and I can click on image classification, and I will see the list of papers that are in this research problem. For the research problem page, we have the description, and we can see also the top authors that are addressing most frequently this research problem. I can see a list of them, and also I can see the link to a Google Scholar, maybe if I'm interested to contact them or something. And also we can see the list of benchmarks here, in addition to the list of papers and comparison and also visualization. And for our case, we are interested to see the benchmark on the ImageNet dataset. And as you can see, we have already more than 200 paper. And if I click here, I will see the benchmark view, which represents like the performance trend of these algorithms or these methods on the data set called ImageNet, and also on a certain evaluation metric. And for this case, it's operations per network pass. And as I see that this is a short list because this metric is not reported frequently in the papers. But if I switch this to top 1 accuracy, as we added in our paper, we will see more papers, and also we can see the list of models that are used by those papers. And we can search for our paper, which is like 90.1. As you can see, here is the first one. And I can click directly on this icon to check the source code for those implementation. And also I can directly from this trend view or this plot, I can visit the paper. Let's say this is our paper, which outperformed the state of the art of this specific research problem. And I can click just on this dot, and it will bring me directly to the view paper. Yeah, I think this is it, what I have to say about the benchmarks and templates. And I think Anna-Lena will talk about observatories in the next section. Okay, thank you for your attention.
Yeah, thank you very much. So indeed, we are then at the last point of this presentation. For that, I'm also going to share my screen now. And so here I would like to talk a bit about, what does the ORKG mean for the NFDI, or what could it mean for the NFDI, and what could it mean for the different consortia? How would they get involved, and why should they get involved? So, and for that, I'd like to start, with a bit of an, show of what other researchers have so far used the ORKG for. So since the NFDI is, of course, consisting of several diverse consortia with diverse backgrounds, indeed, I'd like to show, what researchers from all those different backgrounds have used the ORKG for. And for that, I'd also like to go again to the life system here. And I guess the overall vision that we had in mind for the ORKG was, of course, to have this comparisons of papers here. And you can see, for example, something here from security research. So again, computer science, where people have just compared different techniques for a certain security problem and created visualizations here. But of course, the ORKG can not only be used for computer science, but also really for other fields, and then sometimes also completely different purposes. So for example, here I have an example from medicine or virology, to be a bit more specific, which is where a person has asked a question. and then compared for this hypothesis, how many studies agree or disagree with that certain hypothesis, to just then count in the end. So now maybe this is a bit of a different use for a comparison than what you've seen in the previous talk. But also something that is, of course, interested to some fields, especially fields that maybe not necessarily always have a definite number as an output, but more of a qualitative yes or no statement. They could, of course, also use comparisons for that. Then we've had people come to the ORKG, more from sciences like psychology, where of course a lot of meta-analysis is needed. So for example, here a person has not so much looked at the actual outcome of a study, but more of a from a meta-analysis point of view, more looked into the different samples here to compare them and maybe find if a certain group in this study has been over or underrepresented, which is of course also something you can do for the ORKG. Then a nice little success story here. You could also use the ORKG to convince others, from your work. So we had a researcher who now more or less designs most of his projects in the ORKG and then attaches them to his publications. And apparently it does convince peer reviewers to select his works because they are presented in a structured way. I guess that hopefully also answers a bit of the question that I've seen in the chat, why a researcher would want to edit their research there or why they would want to do something here. Indeed, in that case, it convinced peer reviewers. In other cases, it just made their work a bit quicker, for example, with the meta-analysis. And then yet another comparison here from the field of agriculture that I want to show is a really nice study here about intercropping different, basically on fields. So more for, like really ecology use case here, where the person has also given a really excellent talk about the need for machine actionable data. So if you want to look a bit more in why people say they want to use the ORKG or why they use the ORKG, I could also really highly recommend looking into this, this story here and this talk of that person. So so with that, you have seen that we have really a variety of applications where the ORKG can be used for from all different fields. That we of course also have NFDI consortia in. And you can really see the different things that can be done here with the ORKG. But now the question is, of course, how can the different consortia make the most use of the ORKG here? So really talking about the consortia and not just an individual researcher, an individual person. So and there are really several ways to get involved. So if you ask yourself, how do we get the most out of the ORKG for our discipline? There are really several aspects to this. Of course, you would want to have a lot of content for your field in the ORKG. You would need the right features that are necessary for the thing that you want to do with the ORKG. You need to know the requirements of the different domains, which of course the NFDI consortia do. And you would also need to know the community and be a bit in touch with our community. And all these different things here can be met with our ORKG observatories. So what are those observatories? They are groups consisting of a few people that dedicate a few hours a week to curating content for their field in the ORKG. So what they do is they really help organizing research in their field, ensuring a high quality standard. So they really curate content there and also look at the content from their field to see that it's of high quality. Then, of course, you've seen the templates in the previous part of the talk. And this is something where the observatories can also really help simplifying the use of ORKG for new users by helping to build such templates so that new people already have a kind of guideline as to what are relevant properties and to adding their papers. Also, if you have pre-existing services or, for example, an ontology that you have developed in a consortium, that can, of course, be integrated into the ORKG as well. And this, could also be part of an observatory to integrate and establish some community standards here in the ORKG. Then, of course, we are always happy if the observatories help us with promoting the ORKG to their communities. For example, if we have the same like stakeholder groups and those observatories present their work there, that would, of course, be also a great boost for us. And on the other hand, we, of course, then feature those observatories prominently on our page that is related to the specific content of the observatory. So then our observatories stay in close contact with our development team so that really their issues and requests can be prioritized. So if there's a feature wish that would be useful for a certain community, we are always happy to hear about it, and we try our best to implement it as quickly as possible. So and with all of that, those ORKG observatories really take the lead in content curation for their field and in the open science initiatives in their field. And with that, it's possible to really build a community knowledge graph just tailored to the needs of your discipline here. And if you want to at first get some more content from your field or are looking maybe for an incentive to start such an observatories, I'd really like to highlight our curation grants. Basically, once a year, we start our curation grant program, where we hand out €400 a month to up to 10 researchers who then curate content for their specific research problems and their fields of expertise. So the program runs for half a year, and our grantees get constant feedback from us. So they are really trained in how to use the ORKG, what are the best ways to model the content semantically, and they are closely supervised. We have a chat where they can always ask their questions and get an answer basically within the same day. And we also do bi-weekly calls. So the grantees that have previously participated in the program also, think quite highly of this. So they said it's a nice experience to do that, and they learned something and really were able to, realize some of their projects that they wanted to do with machine actionable data. And those curation grants and the content there could then also be used maybe as a starting point for such an observatory. So, for example, if you're interested in that, you're always welcome to sponsor a grant. We had such sponsorships previously. For example, the ZBMed sponsored a grant for the field of virology, which is one of the comparisons I've shown you came out of that curation grant. And of course, even if you don't want to sponsor a grant, but maybe just send someone from your consortium directly over, they are, of course, also invited to join our bi-weekly calls and join our training, and join basically our curation chat to ask their questions there. So you can always, when we start our program again in the beginning of next year, of course, people from the different consortia are also welcome there, and can also curate content and get their advice there directly in our chat groups. So and with that, we are almost at the end now. I just want to advertise basically one little thing here. So if you don't want to directly go to our interface, you can also use our LaTeX package to directly get your paper into the ORKG while writing it basically just with some really simple LaTeX comments. You can already make a machine actionable description of your paper while writing it. So for the people that don't really like going to a different website or interface, you can also do it directly here when writing your paper. Yeah, and with that, now we are at the end. We would be happy to hear from you via our email address here, or I will also drop you my personal address in the chat later. You can follow us on Twitter and Mastodon or LinkedIn. And you can, of course, always look at our site and don't hesitate to come to us with questions. So just as a brief summary of what the different consortia could do is, of course, you could run an observatory, maybe sponsor a curation grant if you want to initially get some content there. If you're running a journal or a conference, you can also integrate the ORKG into your submission system. And of course, we would always be happy if you use your consortium's outreach to spread the word about the ORKG. So yeah, with that, we are at the end of our presentations and are happy to take your questions.
Well, first of all, thanks to Anna-Lena, thanks to Kheir, Eddine, and thanks to Sören for presenting the Open Research Knowledge Graph and all its facets. It's a quite significant contribution with many different aspects, from the technical contribution in form of a knowledge graph, in form of additional technical constructs like templates, forms, the whole platform that you have showed. And last but not least, not to forget the community activities, which actually bring such an endeavor into the daily lives. So I think this is quite impressive and quite substantial for probably a lot of people. Before we go into the discussion, we close our streaming session here. So let me please thank the whole audience being live here on stage and being in the streaming dienst or streaming service, or maybe even watching the video a little bit later on the YouTube channel. Thank you very much for